I'm not here right now, but through the wonders of modern technology, you can all enjoy, or not, a short lesson presented by me. Well, let's start today with the problem of the day shown here. And I believe I've left a new batch of problem of the day slips so you can get up out of your seat, get a slip off the teacher's desk, go back to your seat, and work this problem for about 5 minutes. And if someone can pause the video, you can all have about 5 minutes to work the problem. If no one's able to pause the video, you're going to see the answer and no one will be able to earn a point for the problem. So if someone is able, pause the video now, and when the time is up, restart the video and you'll see the answer for the problem of the day followed by a short lesson. Okay, I hope someone paused and then restarted the video. Here are the different ways that I got, and if you count them, there's 6, and that's the answer to today's problem. Today's topic is slope. When we graph lines on a coordinate plane, all lines have an angle relative to the x and the y axis, as does the green line here. Mathematicians have decided to assign a number to each line to help indicate its angle on the coordinate plane. This green line is a horizontal line. Horizontal lines are said to have slope equal to 0. This line has a slope of 1/2. This line has a slope of 2. This vertical line is said to have no slope at all. And now as we go the other direction, this line has a slope of -2. This line, -1/2. And then we get back to a horizontal line again, which has a slope of 0. But now it's time to take a look at exactly how these numbers are determined. So let's start with a sample line, and I've picked this line and put it on the graph here. We don't know yet what the slope is. First of all, a line is a collection of infinite points, and the arrows indicate that it goes on forever. But when we find the slope, we usually like to concern ourselves with the points that both the x and the y coordinates of each ordered pair are integers. So I've marked those points here with these dots. These are the points on the part of the line shown here where all of the coordinates are integers. Then you get to select any 2 points you want, and I'm going to select the 2 that I've changed to the color purple. And from those 2, you count from one to the other, the distance up or down, which in this case, if we start with the bottom one, we need to go 6 up to get even with the top one. And then you count the number left or right. And after we go 6 up, we need to go 4 to the right. And we're supposed to put the up and down number on the top of our fraction and the left-right number on the bottom. So our slope for this line is 6/4, and put in lowest terms, 3/2. You might say, how do you know which dot to start at? Well, the beauty of slope is you could start at either dot. But before we try it another way, it's worth noting that up is positive, down is negative, right is positive, and left is negative. So our slope of 6/4 was positive because 6 was up, which was positive, and the 4 went to the right, which was also positive. But now let's start at the top dot and go to the lower dot. Our first move then would be 6 down, which is negative, and our second move would be 4 to the left, which is also negative. -6 over -4 when put in lowest terms, is still 3/2 because negative divided by negative is positive. So no matter how you do it, the slope of this line is 3/2. And there was one more thing I'd like to try. You don't have to choose the 2 points that I chose. So let's choose these other 2 points that I've marked in purple. And from the bottom one, we need to go 12 up, and then to get from the bottom one over to the top one on the left or right move, we go 8 to the right. And 12 divided by 8, when put in lowest terms, is 3/2, just like it was the first time we've done it. So I think we've proven and exhausted the fact that this sample line has a slope of 3/2. And now let's take a look at a horizontal line. Pick any 2 points you want, and your up-down move is 0. And your left-right move is the distance between the 2 points you picked. In this case, they're 9 apart. So 0 over 9 is 0. And our other unusual line, the vertical line. As shown, I've picked 2 points on the line, and the distance between those 2 points up and down is 7, but the distance right or left is 0, and there's no slope because you can't divide by 0. Now let's take a look at today's handout. So someone again may pause the video while the handout is handed out so that everybody in the room gets one. So pause the video now. I hope that everyone has a handout by now. And let's take a look at this first problem that I've circled that has the letter B by it. Our job is to first plot both points. So the dot that I've just plotted is 4, 4. And while we're working these first 2 sample problems, if I go too fast, someone can pause the video at any time and then restart it. Then we also need to graph the second point in that pair, which is 1, 2, shown here. Then I believe the instruction said to connect the points to form a line. So we do that, and we extend the line just past the points and put arrows on the end. Lines, of course, go on forever, but when we represent lines, we can represent as much or as little as a line as we wish. And because we're going to do 3 problems on the same grid, we're not going to extend these lines very far because we don't want to get in the way of the other 2 problems. Well, now that we've done this, we just need to determine the up and down change and the right-left change as we did in the sample problem. The up and down change, starting at the bottom point, we're going 2 up, followed by 3 to the right. So the slope of problem B is 2 over 3, or 2/3. And now let's do the middle problem, labeled with an E. I've already graphed the first ordered pair, 2, 0. And now I need to graph the second ordered pair, -4, 4. And then, just as I did in the first problem, I connect the points. You can use a ruler that are up on my desk, or you could use your ID badge as I did to connect the points as best you can. And then we need to determine the vertical change and the horizontal change. And this time I'm going to start with the higher dot, and I'm going to note that from the higher dot to go down even with the lower dot, it's 4 down. And then from there I need to go 6 to the right. Remember that down is negative and right is positive, so it's -4 over 6, which put in lowest terms is -2/3. The slope of the second line is -2/3. To summarize, slope is the vertical change divided by the horizontal change between any 2 points on a line. This is often called rise over run. I leave the rest of the problems on this handout for you to do. Good luck with them, and I'll see you all next week.